Hello, ladies and gentlemen. Today we're going to be working on the heating curve and phase change notes. This is going to act as the pre-lab for the heating curve lab. We're going to go ahead and start off by making our hypothesis for this lab. So before we get into any of the background information, I want you to go ahead and make your prediction here. Now, what we need to predict is, what do you think is going to happen to the temperature of ice while it is melting? And I want you to make a prediction on what do you think is going to happen to the temperature of water while it boils. Once you've done that, we're going to go ahead and dive right into the notes. Now, guys, make sure you have the notes pulled up in your digital notebook so that you can fill these out while we're going through, because you're going to want to use these to help you analyze the data you collect from the lab. Now, the basics. There are three main states of matter. This is probably something we already know. Solids have a definite shape and a definite volume. The particles that make up a solid have a very strong intermolecular force holding them together. It means that their particles want to hold on to each other and sit right next to each other while they're in the form of the solid. Liquids have no definite shape, but do have a definite volume. Liquids take on the shape of whatever container that they are in. And then gases. Gases have no definite shape and no definite volume. Gases have the weakest intermolecular force between their particles, meaning that they don't want to hold on to each other very well, and they'll spread out very easily. Now, phase changes. Now, anytime a substance, let me move there we go. Anytime a substance goes from one state of matter to another, this is called a phase change. There are 6 different types of phase changes that you will need to know for this course. The common ones that we're going to use the most frequently are melting. This is when a solid becomes a liquid. This happens when energy is increasing in the substance. Freezing is when a liquid changes into a solid. This happens when the energy is decreasing. There's condensing. This is when a gas becomes a liquid. This happens when energy decreases as well. Then there's evaporating. Now, evaporating is when a liquid becomes a gas. This happens when the energy increases. Another word that you might see for evaporating is vaporization. So if you see vaporization anywhere, they are the same two things. Now, the uncommon ones that we'll see periodically are sublimation. This is when a solid becomes a gas. A good example of this would be dry ice. Around Halloween, you might see a bit of dry ice here or there. It's used to create that fog effect when you put it into water. It goes straight from a solid to a gas form. And deposition. This is when a gas becomes a solid. Let me move my camera again. Now, an example of this would be the frost that forms on cars or the ground in winter. When you wake up, you might see frost on the surface of things. That's the moisture in the air being frozen into a solid and skipping the liquid form entirely. Now here, guys, we have our phase change graph, and I've gone ahead and put those 4 common phase changes on the graph. There we go. I've put those 4 common phase changes on the graph right here. We can see freezing, melting, condensation, and evaporation. Now, if we look at the bottom of the graph, we can see that heat is going up to the right and temperature is going up this way. Now, what that means is that as heat increases, our substance is going to melt and then evaporate. We can see that the temperature rises in these few sections. Now, as we take heat away, a substance with a high temperature would then go through condensation, and then it would freeze. Now, guys, I want you to go ahead and, based on what we just talked about with these 4 different types of phase changes, I want you guys to predict or tell me what substance or what state of matter is represented right here by the number 1. How about by the number 2? And then what state of matter is represented by the number 3? Now, guys, if you said solid, liquid, and gas, you are absolutely correct. Solids, again, we can see that intermolecular force giving them that nice rigid structure. Our liquids not having that definite shape here, they're a little bit more ambiguous. And then our gas is going to be a little bit more spread out. They have that weak bond holding them together. And what does this mean? Now, during a phase change, does the temperature of a substance change? Now, guys, you can see that right here and here on that graph. I want you to go ahead and give me your answer. What do you think? Does the temperature of that substance change? The answer is no. During a phase change, the temperature of a substance will remain the same until that phase change is completed. So we can see that we have solid, liquid, and gas right here. But during B and D on the graph, we are undergoing that phase change. It's the same graph as the previous slide, just with different labels. All right. So in B, we're going to have to melt to get from a solid to a liquid. And then in D, we're going to have to evaporate to get from a liquid to solid. Now, this also works in the opposite direction. We can condense from a gas to a liquid going back this way as we take energy away. And then we can freeze as we go from a liquid to a solid. But during those phase changes, the temperature is more or less remaining constant the entire time. It's only when we're in that state of matter that that's going to go ahead and increase. Now, this brings up the question of where does that energy go during a phase change? If we continue adding energy to a substance, normally you'd expect the temperature to go up. But we just saw that that's not necessarily the case. So where do you think that temperature is going? Go ahead and give me your prediction. Now, guys, if you said that that energy was being used to break down the intermolecular bonds that we were talking about earlier, you were correct. If you didn't, that's okay. You can see here in our solid, our particles are all stuck together and very close. In our liquid, they start to spread out. In our gas, they spread out even more. Now, this is because those intermolecular bonds are being broken down, and it's allowing those particles to move around more freely. Guys, at this time, once you've finished filling out your notes, I'm going to have you go ahead and open up the heating curve lab and you can begin your data collection process. Be sure to start with the video in there so that you can understand where you're going to get your data from and how to set up your video or how to set up your graph. Thank you very much and have a great day.